a value as close as possible to the real world value. Right? Let's clear what everything else is a means. Why you are doing? Remember we talked about why, what, and how is very important. Why we are doing it? Because we wanted to develop a capability by which the software program to predict something which is as close as possible to the reality. That was the goal. So what do we do for that? Remember the life cycle is very important. I talked about the 7 steps you need to do to accomplish this, because this is what is machine learning. And you want to predict, you want to develop a system or a program that predict this, and you want to make sure that more experience, this prediction improves. Otherwise, it's a conventional program. If you develop based upon the data you have right now to a prediction algorithm, then it's not machine learning. Machine learning means it has to learn. Remember the definition: a task T, its performance P has to improve with the experience C. So for this, we wanted to make sure that we have data. Data is collected, and what is the next step? Prepared. Once the data is prepared, what we do? We divide that data into 2 sets. First part is used for identifying a model and then training a model. So that's one step. So how do you identify the model? Based upon the distribution of the data, you pick the right model. And once the model is identified, train the model using the training set. So if there are m items in the training set, what you are trying to do? You are trying to develop a hypothesis. What is the objective of that hypothesis? From the input value? No, that's not the goal of the hypothesis. Hypothesis goal is what? Hypothesis is h theta. That is hypothesis. H theta equal to what? Theta 0 plus theta 1x. So it gives you a model. It gives you a model to predict the output based on the input. Correct? What is the next step? Once it is done, how do you validate the model? You want to make sure that most of the data in the training set means is as close as to the prediction. So for that, how do we do that? This is easy to explain theoretically, but practically how do we do? We came up with something called the cost function. So what is the hypothesis? H theta is a function of independent variable x always. Whereas the cost means once you got the cost function, what is cost function? J theta. What is J theta indicates? It is the deviation of, it is the overall deviation, right, of the expected value versus the actual value versus predicted value. Now, what is the next step? Once you identify that, you want to make sure that you're identifying the parameters for the hypothesis optimally. Optimally means what? The cost function is minimum. Cost function minimum means what? The deviation between, exactly. So how do you find that? You identify the cost function, then we applied something called gradient descent. The gradient descent, what it does? It helps us to identify the values of the parameters in such a way that the cost function is minimum. So that parameter, when you substitute, the hypothesis becomes a meaningful hypothesis. So now you have to take the data from the validation set, because we divided the data into 2 portions. The first portion is used for training the model. Second portion is used for validating the model. That's done. You validate the model, fine tune the parameters if there is any deviation, then start predicting. This is the 7 steps. But that step 3, 4, 5, and 6 are very important, because that is going to repeat in everything. Any doubt on that? Okay, great. So let's pick the thread from there, because last week we talked about metrics as a tool for what we are going to do today. So Let me count.
Some of the door locked again. I don't know.
What is that?
People were waiting outside. The door wouldn't open.
Oh, really?
Yeah.
We kept it open.
Yeah, I know. It's like I'm thinking. Someone got locked again.
So what we saw was linear equation with
One variable.
one variable. What does that mean? The output is predicted using
Only one.
one variable. What was the example we had?
House price.
House prices based upon square. But is that reality? 99.99% of the cases, it won't be with one variable. You just, if that is the case, you buy the house based on just the square footage. 55-year-old house and a brand new house, square footage is the same. Do you buy that? With the same price?
Same price, right?
No. So that means in real world scenario, there would be more than one variable. So how do we create, means what exactly we need to do? How do we create a model? Now we need to identify. If you identify the steps, it's going to be very clear. The first thing is, how do you create a model when there is more than one variable? Second question is that relation is linear or non-linear? Because sometimes it might be non-linear. Linear means what? When the x changes, y also changes. Exactly in proportion. Sometimes it increases, sometimes it decreases.
It's off right now. It's off right now. It's not turned on. Yeah, now it's turned on.
Huge distraction. We need to find out.
I'll bring something for this. I have something. We need a USB to HDMI. I got one of those.
Okay.
Unable to connect.
Unable to connect?
Yeah. Did you reboot the laptop?
Yeah. It was connected initially. Like
Yeah.
when with the HDMI headphone.
Reboot again.
So I have to reboot the laptop again.
You might have to.
Sorry. So, meanwhile the laptop is rebooting. Let's talk about the linear equation with one variable. So yeah, no, I was talking about the steps. First thing is, you need to, what exactly is the model going to be? Because when it was linear equation with one variable, it was h theta equal to, or
Theta
0 plus theta 1x. How that model is going to change when it is not just x. Let's say that it is x1, x2, x3, x4, x5, x8. So in that cases, how that model is going to change. What else we need to study or need to understand? Once you identify the model, what is the next thing? Cost function, right? How the cost function is going to change when there is more than one variable. Third thing is what? How do you identify the parameters when it is more than one variable? how do you identify the most optimal parameters when the variable, when it is more than one variable?
Contour plots and figures.
Yeah, that is the gradient descent. Remember that contour diagram is just a tool within the gradient descent. So basically, how to identify the model, how to define the cost function, how to identify the parameter. And one such method was, means in the previous case we used gradient descent. Are we going to use gradient descent or are we going to use something else? Answer is, we are going to use gradient descent, of course. Plus there is another option called a normal function. So these are the two different, because earlier in the case, it was just an equation is identified or a model is identified. We identified the cost function. And once the cost function is identified, we use the gradient descent to identify what? The parameters. So here also the process is the same. Only difference is that identifying the parameters, we use two methodologies instead of one. Where exactly we need to use what? We need to identify. So the framework is clear, right? No doubt. Okay. Let's try and try. So you have to redefine the plug and play.
It's not turned on yet. It's a topic.
You may need to update the software. That's the real solution.
Maybe after the class if you have time.
Sunday, Thursday. Okay, so while getting connected, can you write what exactly is the equation for one variable? What exactly is the model? And what is the cost function? Can you write? Let's start with that. So what is the equation? I know everybody can write the first equation, but what I want to know is cost function. What is cost function here? Cost function. J theta 0, theta 1 equal to.
You're asking for cost for the precision variable or?
What is the value like? Remember, I
One by
unpacked and
half of
repacked.
gram, then sigma 1 from 1 to
1 by 2m
2m.
sigma
I running from 1 to 1.
I equal to 1 to m.
H of I minus.
Yeah, x
Y
of I
minus
yi
the.
whole square. Excellent. That's what we need. So let's say that what would be the model for multiple variables? Let's say that, let's take an example. In that example, the same house price, but the house price is determined by, of course, square footage, plus, let's say that number of rooms, maybe the age, so 3 parameters. So how do you write the equation? What would be the logical equation, or what would be a logical model for this particular case? Imagine that it is linear, not quadratic or anything complex. So what would be a potential equation here? Not connecting?
The same for
That's
the
fine. Find the cost functions for these three
All the
variables
three.
added.
No. I'm talking about what would be the hypothesis.
theta zero plus theta one.
Okay, exactly. So hx, hy equal means hx, but of course h not just x.
X1, X2.
It's h1, x2, x3, x4, right? Because it's a function of not just x1. It is a function of x, and that x is a vector. Remember? Because it is not just a scalar. In the case of one variable, it was just a scalar because only the area or the square footage used to determine the value of the house. But here, it's a function of x1, x2, x3 or x4, whatever it is. If you had identified four values, so it is h. Either you can put capital X, or you can put h small x1, x2, x3, x4. And what would be on the right hand side? Theta 0
Theta zero, theta one.
plus theta 1 x1, theta 2 x2, theta 3 x3, theta 4 x4. That's it. Not that bad. So, as I said, like here, the estimated value is a function of a vector. And what is that vector? x1, x2, x3, x4. And how many parameters were there?
4.
Theta 0, theta 1, theta 2, theta 3, theta 4. 5, right? So, in other words, the other day I talked about a trick. Here you have 5 parameters and 4 variables. So typically what we do, we substitute that with x0, and x0 is always 1. What is the logical explanation of this? Every house will have some minimum value, right? Some minimum value will be there. Oh, thank you. What was the problem?
You have to figure out.
Great.
Yeah,
Okay.
figure out.
We covered a couple of slides. Good. So one note, you have one page for each lesson.
Right.
Okay. This was there already. So here, this is what we were talking earlier, right? So size, number of bedrooms, number of floors, age of the home in years, price. So what exactly we are trying to predict? What is the dependent variable?
Y.
Price
Of course, y is the dependent variable, but in this particular example, what is y?
the price of the house.
Price. Right. And what are the independent variable or variables? Here it is not just one variable. That is why linear equation with multiple variables. Linear equation with single variable means how many independent variable will be there? One. If linear equation with multiple variables, there will be multiple variables. That's it. This is simple. First of all, just shed off the idea that this is complex. This is going to be extremely simple if you know the linear equation with one variable. That's it. So here, let's define the notations. The first, that is the goal of this particular point. Notations here, n means number of features. So in traditional statistics, what you used as variable in machine learning or in the world of artificial intelligence, it is called as feature. So if you want more information, you put 2 books. The first book, that's why I told that to read that first book, which defines the vocabulary and terminologies. But not only I will tell the vocabulary, what exactly it is. You can see. In statistics, traditionally what you called as variable is known as features. So you can see features means within bracket variables. So n means number of variables or number of features. Here x means input features. Y means expected feature or the output value. That's it. So the input feature of means xi means what? So here, if I ask what is x2 here, what exactly is going means when you say x2? Exactly, number of floors. So look at horizontally, because let's say that the whole feature set contains 4 different aspects. Or in traditional programming language, you call it as object-oriented programming. What do you call this? Attributes. Anybody's studied the object-oriented program? C++, Java, Python. Here you call as attributes. What you call as attributes is exactly a feature. So xi means means the ith training example, and then xij means what? Value of feature in the ith training example. That's what it is. So here m represents what? N represents number of features and m represents number of items in the training set. Please pay attention, because otherwise it will just go away. So here I will give you one example. I will ask you, right? So we got 10 training samples. In other words, we got the input variables as well as the price of 10 sales here in North Brunswick. Okay, and we identified that there are 4 aspects you need to consider in every stage. So in this particular case, what is M? 10. What is N? It is obvious, but in every classes, a lot of people make mistake on this. So N means always
The
number of features. That's why I use M very consistently from earlier, right? M means number of items in the training set. Now, here also, right? When you this notation you need to understand. This is very important. Xji means what? Look at that example. X32. X32 means value of the feature J. Value of the feature J. So here X3 means what? Which? Yeah. Number of rows. And like 2 means what? Second. See, the second example in the training set, what exactly is the feature number? This is very important. So this part, this is called as superscript, right? What do you call this?
Yeah.
And this is called
Subscript.
Is it subscript? No.
Yes.
Is it? Okay. Subscript is going to be what?
Feature.
Yeah. Just try to connect with the real world, right? So subscript is going to be the feature, and the superscript is going to be the index or which item in the training set. Okay. So this is clear, right? So let's move. So in the previous case, this was the hypothesis. What is that? H theta x equal to theta 0 plus theta 1x. So we did this already. H theta, H, it is capital X. That capital X should, if you want to correctly explain, it should be x1, x2, x3, x4. So theta 0, theta 1x, theta 2, x2, theta 3, x3, theta 4, x4. So now what we need to do, what exactly we are trying to find out finally? The value of the parameters. How? The value of the parameters in such a way that cost function is minimum. Cost function minimum means what? The probability of the difference between the actual and estimated is minimum. That's it. See, if you know that template, or if you know that 3 steps, everything else is a substitution in that 3 steps. So let's go. So here, so now how do you, using notations and models, how do you simplify this equation? Now you understand why I spent that last class. In the traditional curriculum, it will just, from first session, it comes to the second session. Sorry, this topic. So since we learned metrics and vectors and scalar, this should be straightforward now. So let's say we said x0 equal to 1 for convenience. Why? I gave the logical explanation. You wanted to make sure that the number of features and the number of parameters are the same for the calculation convenience. So the constant you always put it as x0 and then make sure just what do you do? You can always put that as long as the value of x0 is 1. So now this x is a vector. I already explained. What is vector? It is a one-dimensional matrix.
Right.
Correct? That's what it is. So for consistency in machine learning, I said like it can be either a row or a column, but in machine learning, it will be always a column. You can see that. That is a consistent notation we are following. So x is the vector of what? Of features. X is a vector of features. And what would be the dimension of this vector? Which order of? Remember, I already defined the parameters. Remember, m, n, I already defined. So in this particular case, what would be the dimension of this vector? 5, or if it is general,
N dimension
n. I heard n, I heard n plus 1, and I heard n minus 1. Which one? Just
And just 0 to n. 0 to n.
So let's say that earlier 3 variables were there, right? Theta 1, theta 0 plus theta 1 x1, theta 2 x2, theta 3 x3. So 3 features were there. Earlier, means what was the number of features represented by what? M. So if M represents the number of features, oh, whatever it is, yeah, if N represents the number of features, what would be the dimension of that vector? N plus 1, correct? Okay. Now, let's go to the parameters. So if theta is the parameters, how many parameters are there? In our example earlier, 4. Means if it was 3 plus 1. So it's a parameter theta 0, theta 1, theta 2 up to theta n. So this is how you model. Now, what exactly is this h theta x? It can be written as theta 0 x0, theta 1 x1, right? What did I do? Theta 0 x0 and what? Because x0 equal to 1, I can always substitute that. Theta 0 x0, theta 1 x1, theta n xn. And this can be written as theta transpose x. Is this clear?
Will it be that way?
Right. If you have done metrics, if you had, remember, I took the same example last week, very similar example. What is transpose?
Use the identity matrix.
Transpose? That is, inverse is there, identity matrix is there, transpose is there, right? So here, what you are trying to do is transpose. So if theta 0 means what is theta here? It's a, what is the dimension? How many means it's m? Yes, n plus 1 times. I'm just using the matrix notation because we wanted to do a matrix multiplication here. N plus 1 times 1, right? What is the dimension of the matrix? Remember, how do you say the dimension of matrix? Generalize it. How do you do that?
Rows by columns.
Yeah, number of rows by columns. So here, what you have is x is there, theta is there. So how do you, what type of matrix is x and what type of matrix is theta? So theta is 1 by n plus 1. No. Yeah, it is correct. No.
No. N by 1, right?
N by 1.
N by
Yeah.
1.
See, number of rows, right?
Rows N.
So n plus 1. There is n plus 1
By
by 1.
Y plus 1.
Y plus 1. Anybody?
Starting from 0.
Let's take a simple example because this. Okay, so let's say that it is h x equal to theta 0 x1 theta 1 x2 theta 3 x3. So here theta equal to what? Theta 0 theta 1 theta 2. So here, how many variables are there? In fact, this is 1. If this is 1, how many variables were there? 2 variables. So what is the dimension of this theta?
2 plus 1.
2 plus
2
1
plus 1.
times 1 by 1. Correct? That's exactly why. Okay. So what would be x? x0.
0. Yeah. So N.
No, this is x1, x2, x3. Correct.
Yeah.
Okay. x1, x2, x3. And what type of matrix is this? Again, 2 plus 1
Plus 1.
times 1. So remember, last week I discussed one property of matrix. What is that? If you want to multiply two matrices,
Rows in the columns are the same.
right? So can you multiply these two matrices together? How can I make these two matrices together, multiply together? If I reverse one of them, then I can multiply, right? So if it is, just say, it is a 1 by 3 times 3 by 1, then what would be the resultant matrix? It's a 1 by 1 matrix. So what can I means what another option is what?
3 by 1
3 by 1
and 1 by 3.
1 by 3, and then what would be the case?
3 by 3.
So here theta equal to what? What type of matrix? A 3 by 1 matrix, and x equal to again 3 by 1 matrix. So what I am doing now here, theta transpose, and what would be theta transpose? Okay.
1 by 1.
Here in this particular example, theta transpose equal to
N1 plus
n plus 1
1.
by 1, and x is what? N plus 1 by 1. Sorry, 1 by n plus
1
1.
by N plus 1.
1. So then what is going to happen? What means, how can you write the overall equation? Theta transpose by x. So only thing you need to understand is, why did I pick the transpose?
So you made the columns into rows.
So we can multiply.
So that
You can multiply.
you can simplify this. That's it. See, there is no problem in writing the entire equation. That is completely okay. But you wanted to represent that with a shorthand. So how do you convert this into a shorthand? If you take transpose of 1, it becomes theta transpose x. And this is the model of multivariate linear equation. So multivariate linear equation, again, very simple. Just think of, forget the complication. Forget the complication. Let me just recap and make sure that all of you are on the same page. The linear equation means how many features will be there. First of all, identify what is a feature. A feature is the input variable. That's it. So in the case of a linear equation with one variable, there will be only one input feature which is going to give output. Whereas the linear equation with multiple feature, there will be a set of input variable giving how many output? One output. Output is always only one. So if that is the case, in the case of linear equation with single variable, what was the model? X equal to theta 0 plus theta 1x. Can you in your notebook or writing pad, can you model that with the same logic? Because at that time we didn't have to simplify that, because the equation itself, the hypothesis itself was simple. You didn't need a shorthand. So how can you write that? If it is h theta, you can write that as theta 0, sorry, yeah, theta 1 x0 plus, yeah. So how do you use the transpose? How do you write? If it means what means there are two vectors you need to create. What is the vector of theta and what is the vector of x? Can you write? The only way to learn is write. Because otherwise it appears to be very simple, because last week when I was talking about this multiplication, it was simple. Now I don't think it's convinced. Okay, got it? Now don't look at the screen. Can you derive this equation? Without looking at the screen, multivariate equation, can you derive? Let's derive, then move forward. So let me close this. Okay, so let's do. Let's write the
For how many variables?
n. Yeah, let's do generalization. So let's start with each one, right? Let's say what is parameters, sorry, what is features, number of items in the training set, all put the assumption, and then let's do. So keep this in mind. N number of features. M, yeah. And what is X? J, I.
Gateway, the value of this item.
Yeah, that's all good. So let's now with this, can you model the equation and come up with the hypothesis? Okay, everybody got the hypothesis? What is the hypothesis? And what is the last one?
Theta m x.
Okay. Because earlier I heard somebody say M. So M is the number of items in the training sets. So how many line items will be there like this? Yeah. Each item in that M will have how many parameters, how many variables? Clear, right? Anybody has any doubt on this? Because otherwise this is going to be tough. If you have doubt, just raise the hand. Collectively we will help you and we will proceed further.
Can you explain that again?
Yeah. Okay. So, how many variables we are considering here? How many features we are considering? Let's start with that.
N features, N number of features.
N number of features. N number of features means what?
That many.
Output is determined by
The number of features.
Have you heard of the word determinant in matrix? This is exactly what it is. You had a calculation and all, but this is the business explanation. N number of variables or features determines the output value. So if that is the case, can you write a hypothesis, general hypothesis? Let's start with that.
Your vector was your number of features, right?
Yeah, forget all the vectors, right?
Right.
So there are n features.
Right.
If there are n features means what? How many x's will be there?
N x's.
x1, x2, x3, x4, x5, etc., 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 up to xn.
Right.
And how many parameters will be there?
N plus 1.
N plus 1. So for the convenience, what did we do? We added one more. What did we add? We added one more variable and put the value 1 for that variable. That is only for convenience.
Theta 0 x 0, right?
Yeah. So that's what it is. So can you write the model equation? Don't go further, just write the equation. Just write the major equation. Don't simplify it, just write the equation.
When you say equation, you mean the,
Okay, so let me just go one step further,
Yeah.
one step below. If it is a univariate equation, how do you write?
theta 0 to theta.
H theta equal to
Theta 0 x
theta 0 x1 plus,
theta 1 x.
Theta 0 x0 plus theta 1 x1.
Right.
okay, whatever it is, yeah, that's fine. Theta 0 x0 theta 1 x1, good. If it is 2, what do you do?
Theta
Theta
2 x.
Theta 1 x1 plus.
Correct.
Theta 2 x.
So when the number of variables was 3, means how many theta was there?
4 thetas, right?
When the number of variables was 3, the number of parameters was,
N plus 1. Right, four, yeah.
so if that is the case, can you write the number of, in the case of
Will be
3
theta.
variables, n equal to 3, can you write the equation?
Yeah, sure.
Yeah, please. N equal to 3. This is called a mathematical induction, right? So you do 1, 1, 1, 1, 1, and finally you generalize it. Okay. So n equal to 4, what do you do?
Just add another
Plus.
theta 0, theta
That's
4.
exactly what it is, right?
So the last one will be theta
And
n,
if it is n,
theta n.
so in the
X-
when
X
there
plus
were
one, right?
3 variables,
Right.
how many items? How many items were there?
4.
Total? 4. When there are n variables, how
Will be
many
n
items will be
plus
there?
1.
That's all I was asking.
Okay. So,
That's it. So how do you write it?
yeah, I got it.
Theta 0 x1 theta 1
Theta 1.
x theta 0 x0, sorry,
Theta x0.
theta 0 x0, and put x0 will be 1 always. Theta 1 x1, theta 2 x2, theta 3 x3, theta 4 x4, theta 5 x5,
Theta
dot 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 dot,
Yeah.
theta
N.
x
Theta n x n plus
xn.
1. Yeah, x n, right.
Because remember,
So you started with x 0.
I covered this last week by saying that there are 2 ways to index. I said there is a 1 based indexing, and remember I said like 0 based indexing, and this is a classic example of 0 based indexing. So if that is the case, in this particular case, can you model these parameters and the variables as 2 vectors? Let's do that for example with 2. So if it is 2, you already wrote the equation.
Mhm.
If the number of variables was 2, the equation was what?
Theta
Theta 0
plus theta
x0, sorry. Yeah. Yeah,
Theta
correct.
0 x 0, yeah.
If
Create
in
a
that
vector like
case,
that, yeah.
means what would be the vector of theta and what would be the vector of x?
Theta 0, theta 1, theta 2.
Correct.
4.
Correct. It's a one vector,
One vector for
And
theta,
then
one
what is
vector
the-
for x's.
yeah,
x1 and x2.
x2.
Right.
So how can you simplify that equation into a generic form?
Transpose the first
Yeah,
one.
so if you means first write theta.
Sure.
And I want you to write theta transpose. And then I want you to multiply theta transpose with x and see whether you got the original equation. That's it.
Then come again, what is actually we need to do?
Yeah, what you need to do is you need to write the hypothesis for 3 variables or 2 variables. I don't know what exactly I said. 2 or 3.
So theta 0, theta 1, theta 2 would be the first.
Okay,
vector.
it doesn't matter. Whatever means
Right.
you will get accordingly the answer, right? That's all. So let's say that it is 2 variables or 3 variables. 2 variables, we said.
Yeah,
If it is 2 variables, then
First vector
what is the hypothesis? Write the hypothesis first. You got it.
Yeah.
And what is the vector of theta?
Theta 0,
Vector of
1.
theta means what? It is the vector that represents the parameters.
Right.
There are 2 vectors. One vector represents the parameter and the other vector represents
The
no features.
features. The x,
Predicted value will be always 1.
One.
x is the features.
So
The second vector will be x1 and x2.
X0,
x0, x0,
x0,
x1,
x1 and x2. You're right. You're right. Why did we add x0? Because we wanted
To make it multiplication, we need
we wanted to simplify it. Exactly.
So now you two vectors with the same number of
So
rows
the,
there.
what is the dimension of the first vector and what is the dimension? What means theta is of what type vector?
It's a three rows.
Theta means what? 1, 2, 3.
One column.
3 by 1.
3 by 1, yeah.
And then x is of what?
3 by 1.
3 by 1. You cannot multiply or you cannot simplify using a 3 by 1 and 3 by 1. So 1 has to be 1 by 3.
Right.
So you
In order to do 1 by 3, you need to transpose the vector.
exactly
To make it go to 1.
correct. So you transpose theta instead of theta.
Transpose X.
You can transpose x also.
You transpose theta, why can't you transpose x?
You can do
You can do that.
you can do that. You can do that. That's fine.
But the end result is going to be the same.
End results is going to be the same. See, remember we studied one property called.
Okay.
We studied that property. Means I'll explain that a little bit further down, right? So in this particular case,
Diagonal values have to be matching. Right?
which one?
The diagonal values in the matrix should be matching for you to transpose. Is that what you mean?
Yeah, no, means that is an exception. We are going to come. Means degenerate. We used that term last week. But I'm not going to complicate that right now. We'll come back to it. So right now, means let's assume that the first one is a 3 by 1 matrix. Theta is a 3 by 1 matrix. And x is also a 3 by 1 matrix. And I cannot simplify a 3 by 1 matrix times 3 by 1 matrix. So for that, what I did, I
Transpose
used
theta.
transpose and transferred the first vector, the theta into
Transpose X.
1 by 3. You made it into 1.1 by 3.
Theta.
Transpose vector.
yeah.
Any one vector we can transpose.
Any one vector you can transpose. Just for convenience, let's say that the convention is always theta. So you transpose the theta. Means when you theta transpose is what? Can you write it?
It's a 1 by 3 now.
Yeah.
So theta one double
Instead of a column matrix, you get a row matrix. Theta 1, theta 0, theta 1, theta 2. And can you multiply these two?
Sure.
Yes, it will be the same.
Yeah.
That's it. That's it. Anybody has doubt means I'm not clear because I'm not satisfied with the faces. Anybody who is not clear, let's clear it.
So it will be easy if you're making the vector multiplication and then derive the equation.
Yeah, I did that. It's there. This is what it is. Equation. Look at this. It's there. So extending this further, can you write the hypothesis for n number of features? Everybody has to write, and it should be, if meaning write means if you're not clear, I'm not imposing upon you, because just to make sure that you follow it. That's it. If you're not clear, get up and tell, because I can do that taking a whiteboard and I can execute it for you if you want.
Very good.
What?
No, I got it.
Yeah. Anybody who is, getting is one thing, but anybody has any doubt? If anybody has any doubt, I'll take a blank sheet and execute it. Because when it goes to neural networks, I'll just say that theta transpose x. That's it. So it should be clear that. Probably I'll do it. See, the eyes are the best communicator. That is whiteboard.
You just go down Microsoft like M. You go down M. Yeah. M.
There.
No, keep going down. MS in Mary. M all the way down. Keep going. Keep going. Keep going. A little bit. Right there. Next to that Teams, Microsoft Teams, it's right hand. You see?
Okay, so just give the attention. That's good. Don't worry, if you take a little bit more time here, it's okay. It's really worth it. Wow.
Is it?
The previous note?
I don't know. Is it?
Yeah.
No, but We'll have to check.
I have no idea.
If you just scroll down or up on the left side, maybe, you know, can you move or anything? No.
It's not stored. Stuck. Oh, it's black. It was from the previous session. Okay, so h of x equal to theta 0 plus theta 1 x1. So this can be written as theta 0 x0 theta 1 x1. No question, right? So how do I write it down? What would be the theta vector? Theta 0,
Theta 0, theta 1.
theta 1. What is this? This is a
2 by 1.
2 by 1 matrix, or I can say that this is a
Vector.
two-dimensional
Vector.
vector. And x is what? This is theta.
Same thing.
X0.
X0, X1.
x1, whereas this x0 value is 1. And this is again
Two dimensional
2
vector.
by 1 matrix and 2 vector. So what I'm trying to do here, I'm only trying to simplify this equation. Here it is only 2 items, I can just write it. And imagine if it is n and that n happens to be 25,000, which is pretty much possible. So if I try to write all these values in a problem solving case, it is going to be difficult. So I need a simplified way of representing this. So how do I do? Because can I multiply these two? Can I multiply theta times x? This is wrong. Why this is wrong? Because this is 2 by 1 times 2 by, sorry, yeah, 2 by 1. So this is not same. Because if a matrix needs to be multiplied, remember the rule I stated very plain last week?
Yep.
The number of columns of the first matrix should be equal to the, so in this particular case, that is not the case. So what can I do to one of this matrix so that it can be multiplied? So what I do here, instead of theta, what I did, I took theta transpose. Transpose means you just shift the rows into columns and columns into rows. So this will be theta 0, theta 1. So if that is the case, what would be theta transpose x? It is theta 0, theta 1 times x0, x1. How do you multiply matrix? Theta 0 times x0, x1 is, sorry, theta 1, x1. Isn't it what h of x? So in that case, can I represent h of x as theta transpose x? I said only this much. So a couple of things you need to understand. This is, now it's easy. When you generalize, you need to understand if there are n features. Remember what is feature? Feature is the set of input variables. Feature. No, parameter is not feature. Feature is the set of input variables. Whereas theta is the set of parameters. If there are n features, what would be the dimension of the feature vector? The first one is known as feature vector, and the second one is known as parameter vector. So if there are n features, what would be the dimension of that vector? N plus 1. Earlier when we discussed, I got n minus 1 and n plus 1. Is it clear now? And if there are n features, traditionally how many parameters would be there?
N plus one.
N plus 1, because there will be always a constant. A constant plus constants times variable. That is the model. That is the linear model. Because think of this. You have to think of this like this. If the house price is like this, any house will have 100K. Means I'm just making it up. In any house you buy in North Brunswick, it has 100K. And that is the theta 0.
It's constant.
If that type of relationship is not there, the equation will be like this, and value of theta 0 will be 0. If you remember on the first class, I showed 3 snapshots. If theta 1 equal to 0, what does that mean?
X-axis, right?
Means that variable do not have any influence on the output. If theta 0 has a positive value, means what? The y-intercept is not 0 in your olden language. And if theta 0 equal to 0 means what? Y-intercept is 0, that means there is no minimum value. The prices in North Brunswick should be 0. If at all, the square foot is 0. That's a theoretical scenario. But the thing is, any house you buy, because usually it will be like that, there will be a minimum price. Then plus accordingly, depending upon the features, it will vary. Okay, so with that, if you say, what is the generic equation? H of x equal to, I'm going to write it originally, theta 0. Anybody has any question? So this can be written as
Theta transpose.
just deriving everything. And this theta 0, sorry, this x 0 is 1. So technically these two are same. So this means, what is the theta vector here?
Theta n.
This is of times 1. And what is the x vector?
X0, X1.
And this is times 1. And if that is the case, what is theta transpose? Theta 0, theta n. What type of matrix is this? 1 times.
1 times
Yeah.
n plus 1.
And if that is the case, h of x equal to transpose times
of x.
x, where theta is a vector, x is a vector.
So it should not have the comma.
Which one?
Theta 0, it's not theta 0 comma theta 1, right? Theta 0, theta 1.
Yeah. Notation. Correct.
Wait a second.
Yep. Good. Any question? And just stopping here, because here afterwards it is going to be theta transpose x. So if this is not clear, raise the hand. Don't overlook, because last week I said this same thing. Okay, that's good. Okay, so this is the case. Let's move on. Okay, so this is what we said earlier. The hypothesis, h theta x equal to theta transpose x which is equal to theta 0 x0, whereas x0 equal to 1, theta 1 x1, theta 2 x2, theta n x. Is that first line crystal clear? Good. So what are the parameters here?
Thetas.
Theta, it's a vector theta, or the constituents of the vector theta equal to theta 0, theta 1, theta n. Okay, and what is the dimension of that vector?
So
Dimension of the vector is?
1 by
No, dimension of the vector. Vector, you just say n plus one. You're right if it is a matrix, and if you call it as a matrix. Of course, the vector is a special kind of matrix. Why don't you call it as 1 always? Because it's implied.
Right.
And then, what we are going to do now, we wanted to calculate the cost function. So earlier, how did we calculate the cost function? Same equation. So earlier, the cost function was j theta 0 theta 1.
Right.
Earlier, correct? Now we just expand that to theta n, and it is represented as j theta, which is equal to, what is the formula? 1 by 2m sigma 1 to m. Don't put n there. I see a lot of people when they interchange m and n. Once again, what is m? What is n?
N is the number of variables.
Features. Yeah,
And then
correct.
n is number of features.
And m is the number of samples. So here, when you why you calculate only the number of samples? Because see that if you use the hypothesis, for every sample you will get a result, predicted value. You wanted to make sure that for every sample, there is a difference between predicted value and the actual value. You wanted to make sure that, yeah, the sum of that deviation is a minimum. It's like the standard deviation, just like you calculate the standard deviation. So this formula essentially stays the same. No difference. But execution of that formula, earlier the loop was executing only 2 times. Here the loop will be executing. How many times the loop will be executing? Yeah.
M times.
M times the loop will be executing. Why? Because there are m items in the training set.
Right.
Don't make it overcomplicated. It is not. Okay. So once you calculate that, what would be the next step?
This j theta is a vector, right?
Yeah, theta is a vector. This theta is a vector which
So all the
constitutes
thetas of
yeah, because if you want to write theta
Yeah,
1 to
each
50,
of
yeah,
them, sir.
yeah, it's a collection. It's a vector. Remember, we differentiated between what is scalar and what is vector. Vector means more than one elements. Okay. So now, what would be the next step? Gradient descent. What is the objective? But before you go to gradient descent, what is the objective of gradient descent here? What exactly you want to identify now? So you model the equation here. Cost function is identified.
Find
You want to identify the value of theta 0, theta 1, theta 2, theta 3, up to theta n, such that j theta is a. Earlier it was very simple. You needed to identify only theta 0 and theta 1. Here assume that there are 99, means there are 99 features. 100 values you have to identify. Imagine manually calculating that. You first have to solve for theta 0, theta 1, theta 2, like that, theta 99. You have to calculate. And each of these theta should be optimal so that it's minimal. Remember, when there was theta 1 and when there was only theta 1, it was a 2-dimensional diagram. If you remember, what did I do? Like, it's traveled like this. And when it became theta 1 and theta 2, it became a 3-dimensional picture, right? So at that time, we had to use contour diagram to approximate it. Now, what do you do? What would be the dimension? What would be the dimension? n plus 1.
100 times.
N plus 1. And how do you calculate this? That's what we have to see. It is very difficult to visualize. I don't think anybody can visualize beyond more than 3 dimensions. See, you see 4D movie. 4D movie, it is not visual. The 4th dimension is always a touch. Correct? So when you see that in a screen or anywhere, you can visualize only 3 dimensions. This is n plus 1 dimension. Okay, so this is the formula. So gradient descent formula is going to be repeat for each theta. So first you have to calculate what? Theta 0. And then you have to calculate theta 1, theta 2, theta 3, theta 4, theta 5. It will be a loop until theta n. So that is what is repeat for everything with j equal to 0 to n. J equal to 0 to n means how many indexes?
N plus 1.
And simultaneously update. Why? Because I showed the other day. If it is not simultaneous, the second value will be influenced by first value. In other words, what you need to understand is you're deriving the value of each theta independently. Each theta, that is why simultaneously update. You have to calculate theta 0, you have to calculate theta 1, theta 2, theta 3. Once you complete the iteration, then go to the second. Otherwise, what is going to happen? The value of theta 0 is going to influence the second iteration of theta 0 is going to influence the first iteration of theta 1. We don't want that to happen. So that's why simultaneously update. So the formula remains the same. Only thing is that the only change is what? The dimension changed. Earlier it was, initially we started with 1 dimension. Then we moved to 2 dimension. Now naturally it went up to n dimension. That's it. Pause. Any questions?
What is the simultaneous update again?
Simultaneous update means, so remember means initially when we are calculating theta 0, let's assume that this is simple, theta 0 and theta 1. So first, what you have to calculate, what is gradient descent? You wanted to calculate theta 0. And then means you want to calculate theta 1. So how does the gradient descent work? Remember the formula of gradient descent? There was a learning factor and there is a partial derivative. So what you are trying to do is, let me just go to the here. So this is the value of theta. This is the value of j theta. This is how we predict it. The gradient descent is always a function of parameter, whereas cost function is always a function of variable. Remember we said that. So let's say that when the value of theta was 0.5, the cost function is this. And what do? You try to change the value of theta. It comes here and it goes here. So first you wanted to find out the value of theta 0. So you want to find this value. This is the optimal theta value, right? So if it is theta 0 and theta 1, what did we do? This was kind of contour diagram, right? So you said this is theta 0 and theta 1. So simultaneously update means, first what you have to do, you have to find the value of initial, it means you need at any point of time, if you take this coordinate, this will have, means a particular theta m, theta 0 m and n. No, let me not use mn because that has a different xy, let's say that x and y. So this value means theta 0 value equal to x, theta 1 value equal to y. This is the minimum. So you need to identify what exactly is the value of theta 0 and theta 1 so that the gradient descent is minimum. So for identifying any coordinate, you need both theta 0 and theta 1, correct? So if I want to identify this coordinate, the theta 0 value is different and the theta 1 value will be different. So if you want to identify the cost function, you need to identify both parameters. So how do you want to calculate the both parameters? first simultaneously update means first you want to calculate this theta and then you want to calculate this, because if you wait here, if you calculate the two different theta 0 value and try to calculate this theta 1 value, what is going to happen? The theta 0 value is different.
But how can you calculate the supplementary? Once you see the data, then you immediately get the data.
No. How do you calculate? What is the formula? Theta. What is the formula? Remember, what is the formula of gradient descent?
So that
This is the formula.
d by,
So if you substitute here, so theta 0 equal to theta 0 minus dy by dx, whatever is that value, you have to substitute. So first you calculate theta 0, and then you calculate the next iteration of theta 0. Because what do? You change the alpha. Remember what is the alpha? Learning curve, learning factor. So you calculate the second instance of theta 0. And then if you use that second instance of theta 0 to find the first instance of theta 1, that is going to be wrong. I'll show you that once again to be sure. That is what is simultaneously happening. I'm going to show you the example. So this is the specific formula. So theta 0 equal to theta 0 times alpha. Remember I said like this is the partial derivative. Using calculus, this is the partial derivative. This is what we covered on first class. So here simultaneously update means first you calculate the first value of theta 0 and theta 1 and check what exactly is the cost function associated with that. And then what do? You calculate another value of theta 0 and theta 1 and see where exactly is the cost function lands. So what I'm saying is that if you calculate, means if you do the theta 0 iteration first, what would be the value of theta 0? The last calculated value. If you substitute that with the first iteration of theta 1, it is going to be wrong. So don't worry about that. Just say that you have to individually calculate theta 0 and theta 1 every time. That's it. And if you want that in that notes, I put using a temporary variable, I try to show that. Okay. So thus, how am I going to generalize? How am I going to generalize this particular value? So can I write this value, right? So this is what I try to show you. Can I write this value? Because what is the difference between theta 0 and theta 1? Theta 0, you are not multiplying that with x, because x0 is always 0. So when we generalize it, what do? We put x. That's it. This is simple. So no, I may have to do it. Let me do it. So let me do it here. Theta 0. Alpha times 1 by m c 1 xi minus 1. Xi. This is the formula of gradient descent. This is what we said the other day. So here in this particular example, what is the difference between this formula and this formula? Only difference is that this factor is missing here. Is that? Wow. Okay, so that means the first lesson is not revised, because this we covered a lot in the first lesson. So first lesson. Okay, I may have to go back to first lesson. First lesson is what? First lesson, what did we do? We defined the gradient descent. how did we define the gradient descent? Gradient descent formula equal to, let me write it down. Theta, I would say J, equal to theta J minus partial derivative of this was the formula, if you remember. No? So what did we do? We substitute this value with the actual value later.
I think what happened is we lost that document, right? That's why.
Yeah. Don't worry. So this is the formula. So I'm going to do, let me just do it. All right. So theta J equal to theta J minus alpha times partial derivative of J theta x. This is the formula. So how do you substitute that? But before that, when we did that, I explained why this is needed. What was our objective? H correct? And what was our objective? We plotted something. We said this is your hypothesis and this is your actual value. And we defined what as cost function.
Great.
Right? Remember? We did these things. We wanted to make sure that J of theta equal to, what was the formula? 1 by 2 m sigma 1 equal to m x of I minus y I the whole square. This was the formula, right? So what does that it implies? That is what I would like to know. If you remember, at that time I said, like, practically what you do, the difference between this is the actual value and this is the estimated value. In this particular case, it is 0. And this, let me say, A, B, C. So here it will be A square plus B square plus C square divided by 2 of M here is what? 1, 2, 3, 4. This is the cost function. So this is what we are trying to do. So for me to plot this graph, what exactly is the information I need? I need to know a value of x, correct?
Right.
I need to know the value of theta 0. I need to know the value of theta 1. The training set is always going to give me something. What? The value of x. The training set is always going to give me the value of x, which is the square footage. Right? But the training set is not going to tell me something. What? The value of theta 0. The training set is going to give me the value of y. Because in the training set, I always have a actual value. Okay, so let's draw the training set. So square footage price. Okay, so you had 100, say 500 square foot. You have 100K. You have 1000 foot. You have 200K. So this is what is this? This is x value and this is y value. So when I plot, this is x, this is y. So what I have, say 500, sorry, yeah, 500, 100, 500, 100. I got some value. this much I got. But with this, I have two values, right? I got the y value, I got the x value. What is y represents? Actual value. And what is x represents? Correct. So for what else I need for calculating the cost function? I need an estimated value.
Also,
There is something that is missing now for me to calculate the estimated value. What? Theta 0 and theta 1. How do I find theta 0 and theta 1? What exactly is the process I am following?
Create a hypothesis.
Correct. So that is what I, so we got it, right? We got the hypothesis. X equal to theta 0 plus theta 1 x1. Okay. So I got the value of x1 already from the training set.
Right.
But
Plus,
I don't know.
theta 1.
So I need to find out theta 0 and theta 1. So what I use what? Gradient descent to identify theta 0 and theta 1. How do I use gradient descent? I use a formula, right? What is that formula? I said we will randomly select a value for theta 0 and theta 1, and then I repeat this,
To see how close you can get.
how the gradient descent goes, right?
Right.
So when I calculate the second iteration, if the cost function goes down, that means
You're in the right direction.
right direction. So, but I have to start somewhere, correct? So I just assume a point, and then from there I start. This is the whole concept of gradient descent was.
Right.
If that is clear, now it is going to be very clear. We are extending that to multiple variables. So I have a value of theta 0, theta 1, theta n. I need to start somewhere, and I need to fine tune each one of this so that
The cost
function is a
minimal.
So what is the formula we are going to use to calculate, to fine tune?
The fine tuning is all simultaneous also.
Yeah, means I'll come to that.
Sure.
First thing is just pay the attention. Like say, like if it was theta 0 and theta 1 is there, I need to means I identify an initial value for theta 0, and what I need to do, I need to fine tune that theta 0.
Rajesh, how do we apply those values in the gradient functions with the text, with the formula?
That's the formula for that.
So that we have the alpha and we have the derivative, right? So the alpha will be your learning with, so the theta 1 value would be the value what we found. Theta of j, that would be my theta 1 value. Right?
You start with an initial assumption for the theta 0.
Okay, and then what would be my alpha value then?
You have to start with an alpha value. Remember last time I said you can have a larger alpha value. If it is a larger alpha value, what is going to
Would
happen?
be away.
Away from, sometimes the change is so high that you may miss the actual, right?
Global.
If it is too slow, what is going to happen? It may take more iterations. So what the process here is, you identify your initial value for the theta 0 and theta 1. You pick a value for the alpha, and you substitute that in the formula to see whether it is going in the right direction. That's all gradient function is. So just the same thing we are applying here.
So say in this case, you have, you start say 50K, right?
Yeah, so I'm just assuming that theta is equal to, theta 1 equal to 0.5 and theta
In
2
this
equal to.
example, Rajesh, 500 and 1,000 square feet, what would be the assumption that you?
I'm just going to make sure, I'm just going to say that theta 0 equal to 100 and theta 1 equal to say 500. Let's say that. See, what you typically do is practically you plot the actual values. See, already you have the actual values. So you got a diagram like this approximately, right? And in that approximate diagram, what do? You see, you try to connect these diagrams with the maximum coordinate that you have. Suppose this. So this would be your assumption for theta 0, and then approximately you put a value for theta 1. And then using gradient descent, you are fine tuning this value. So the job of the gradient descent is you are fine tuning the value of theta 0 and theta 1 so that it touches the maximum line.
Can we just take 5 values and try it on this one?
Which
like say if you have the X and the Y, right? So you have 50K, 100K, 200, 250, whatever, 5 values, and you have the Y for the prices in the square feet.
Yeah, let's try one example. So let's say that, give me a training set. I think we had a training set earlier.
Yeah.
Let's go and take that training set. Can you plot this? Let's say there was a linear equation. So let's take one equation here. Let's say the number of bedrooms. Okay, that's the next one.
Just the square feet.
Square foot, okay. Price. Square foot, let's say that, give me some numbers.
50,000 square feet, 100K.
One, let's say that it is
Yes.
square foot in K.
Sure.
1,000 square foot,
Yeah.
2,000 square foot.
Right.
3,000 square foot, 4,000. 5,000 square foot, okay?
Sure.
So, and give me some price. 1,000 square foot means,
100K.
this is in 100K, okay?
Yeah, so 100K. So
This will be, say, 2.
2. Yeah.
This will be 3.5. This will be 7 or 5. This will be 7.
Yeah.
This will be 8. Let's put that. So first what you can do is you can plot the actual value. So this will be 0, 1, 2, 3, 4, 5. So this will be 2, 4, 6, 8. Okay. So what was the first value? So this was 1, you had 2. And when you had 2, it was 3.5. This is approximately here. Then when you had 3, it was 5. Then when it was 4, it was 8. 7, yeah. It is 7. So this was the actual value. Okay. So if you plot this, right? You can assume that approximately theta 0 is 2 and theta 2 and theta 1 equal to what?
How are you plotting that line that you just plotted? Did you just
No, I try to connect with maximum dots. I'm trying to draw a straight line because these were the points, right?
But you would have to have some values for that, right? To just plot it.
No, actually, using the value, I already marked the coordinates, right?
Right.
And then I can just try to connect maximum. What is my goal? I want to touch maximum goals in one straight line.
Right.
I can do that. Why do you need another parameter for that?
How are you just drawing the line? I mean, using what? I mean,
The algorithm is gradient descent, but visually you can do that.
okay.
So here in this particular case, I just started with, means this is just for a,
It's a
if you
regular
plot a graph,
plot.
if you plot a
Yeah,
graph,
no,
you can do that.
Values.
Yeah. This is exactly what I did. If you plot a graph, you can do that. So you identified a value of the theta 0 and you identified a value of theta 1 as approximately 2. Let's assume that.
Theta 0, you made it as 2, right, Rajesh?
Theta
That is
0 equal to y
because
intercept.
y
This is 2.
intercept.
Yeah.
Okay.
Theta 1 equal to slope, essentially. So this is, I put temporarily 2 and 2. So now the question is what? If I use this theta 0, 2 and 2,
So you assume theta 2 into you draw a line, basically, right?
No, the actual values,
Right.
because he had it
No,
like
but
the,
that would go like that, right? Because if you try to intersect everything, you can't just draw a line like that.
no,
No, it
what I
was
said
not a
is
straight
it should
line.
touch the
It was
maximum number.
maximum.
Let's say that 5 coordinates were there. How can I draw a straight line that touches the maximum line? It may not be all this 5. Here in this particular case, it touched only 2. Here in this particular case, it touched only 2, this straight line. Otherwise, other option is what? I can draw another straight line like this. That is another option.
No, I understand what you're doing, but I'm saying physically you can just draw a line.
Mm.
Just, you come in close to the
Mm.
dots. But on a computer, like when you
Gradient descent, that's what we
how
are
do you
going to do that, right? Means I'll show you a problem.
Okay.
But let's understand the concept first.
Okay.
So if it is theta 0 and theta 1 equal to
Not
2,
showing up.
Yeah, it's connected.
Oh, it's-
oh, it's done.
It's straight.
So I
just lost connection.
It's not done yet. So what am I doing here? So I got a value of for theta 0 as 2 and theta 1 as 2. But now the question is what? If I substitute that parameters in my hypothesis, what is the hypothesis? X equal to theta 0 x1 plus
theta 1 x1.
theta 1 x1. I substitute that 2 and 2 in the equation.
Sure.
And I have an actual value.
Right.
So when I substitute that initial means substitute a value for the theta,
You get the
that's
value
2
of
and 2. When I substitute the value of x, I got a value of y. So I can always compare what exactly is the
the real
estimated
value.
value, what is the actual value. And I calculate the grade cost function. When I calculate the cost function, what is the next iteration? I change the value of theta.
Right.
And I also calculate the value of cost function. If that cost function is less, which theta should I take?
The previous
The second one.
second one. Sorry.
Right.
Second.
And then I do one more.
Yeah.
Then the cost function is further going down. That means what?
You're in the right direction.
The theta is getting better.
Better.
So then I'll take that. I did one more change to theta. Then what is going to happen? It is going up. So that means what?
The previous one.
That is
Previous
not
one
correct.
also. Previous
So I'll
one.
go back. So that will be the final value of theta 0
Theta 0.
and theta 2. And what I was trying to do in that particular example is, I was trying to put a general function for that. So if this is clear, now the general function is going to be clear.
Rajesh, you did a graph between theta and j theta, right? The parabolic.
Yeah,
So that is a graphical representation
the
of.
graphical representation of what I just said.
Okay.
What I just said is that because if you take the j value, initially whatever initial assumption of theta 0 and theta 1 gave me this. The next one gave me this. That means what? My theta is improving. The third one, it is further improving. Then it going up. That means what? It's gone. Oh, where? This is. Oh. I need to fix this. Okay, so probably it's 9 o'clock, so probably we'll stop here. We'll recap and stop here. Because this is getting tough. Not tough, but one request is just go over the notes. And if you have any question, post that prior to the class, and that's why I can come 30 minutes early if you want to do something. So that would be fine. So let's talk about that once again. So today what we started was, that's fine, we'll stop here. The notes is already there. If you recap, what we saw the other day was linear equation with one variable. And now what we wanted to do was linear equation with multiple variables. Because in real world, the features are not just one. And what we saw, I hope that is clear at least. Writing the general equation, because there also some hiccup was there, but when we did the whiteboard, hopefully that will be clear. What is the general equation? H of capital X equal to theta 0 x1
X1.
theta
0 x0. X0.
theta
X0
1
plus
x1
theta
theta
1
n xn.
Xn, right.
So this can be simplified as theta
Theta
transpose
of
x.
X, right.
That's where we took a lot of time.
Yeah.
Why theta transpose? Because theta is what type of vector?
Theta is a
It's a n plus 1
n plus 1 times 1
one matrix. Whereas x is also n plus 1
matrix.
by
By
1
one
matrix.
matrix, right.
So you wanted to
Transpose
transpose
the
theta, so that theta became what?
became a
1
1
by n plus 1.
Right.
And x continues to be n plus 1 by 1.
By 1.
And when you do that, what happens? You get one
You
value
get one
because you need only one value prediction.
Right.
Correct? So that was clear. And then we discussed, once you create the hypothesis, you need to identify just like I said, unit means you have the x values, you have the y value, but what you don't have is thetas. So thetas means you have to identify theta 0, theta 1, theta 2, theta 3, theta 4, theta 5 up to theta n. The problem is how to calculate this theta 0, theta 1, theta 2, theta 5. So what we said is you have to calculate the cost function and you have to use the gradient descent. So initially you will start with one value for all these theta, and then you repeat this gradient descent so that your cost function is a minimum. So the gradient descent is calculated for each theta, because I said in the previous case, you cannot just optimize theta 0 alone. You have to optimize both theta 0 and theta 1. So for each parameter in your hypothesis, you have to do this. For each parameter, you have to identify what exactly is the optimal parameter. And you have to do that simultaneously, because the cost function is a combination of all thetas.
Right.
So first you have to calculate one value for theta 0, theta 1 up to theta n, calculate the cost function, and then you have to change all the thetas and see another cost function,
Right.
and you have to compare from the previous cost function and this cost function. If the new cost function is less than the old cost function, I'm going in the right direction.
Right.
If the new cost function is greater than the original cost function, then I'm wrong.
Right.
I may have to change my direction and
Right.
see if I traverse in the opposite direction, right?
Right.
Remember the other example, the one example I showed, like
Parabola.
in the parabola 2-dimensional, like I said, like if I take here, it can go down. If I take here, I may have to reverse travel.
Right.
So I need to check both the option in such a way that I get the minimum value of the cost function. When I get the minimum value of the cost function, I know the value of theta 0, theta 1, theta 2, theta 3 up to theta n. And already I have a pool of value for the x1, x2, x3, xn.
Right.
And using that theta 0 and the theta x1, I calculate the value of the y, right?
Mhm.
And I already have a y,
You
and I compare.
Look the difference.
That is why I test the model. And once the model seems to predict well for the values in my training set, I go take the second set of data. Remember, the
Correct.
pool of data I have, I take half of the model data to train the model,
Yeah.
and the second half of the model to
Thank you.
fine tune the model.
Fine.
So once I find the optimal value of the theta, I will take the second half of the training set and apply and see. So I may have to fine tune the value of theta once again.
Right.
So now I got the confidence. Then I say that, okay, this is the model for predicting the house in the north. Is it clear?
Yes.
Sorry, this is MSc math. You won't even study in bachelor's. Okay, so if it is taking time, it's okay. It's understandable. I'm sure none of you have studied this in schools and colleges, right? Anybody did the math?
Actually, it's a fitting a straight line, chi-square, all this stuff we are studying.
Oh yeah. That is there. That is in a high school, right? The 10 plus 2 is
Follows the same thing.
correct. It follows the same thing. It is just to the next level. Any questions? Anybody has questions, they can stay for 10 minutes. Since others, they can leave. Oh, the official thing is over. Anybody have any questions?
I think we lost the notes, that's why everybody's like. kind of-
Yeah.
That's why.
Is it recovered, the notes?
No.
Have it?
No, I'm recreating
Creating.
it practically. It's another,
Another job.
but then today's note is already there. You all have it. It's already checked out. Anybody has doubt, just sit with me one-on-one for 5 minutes. It'll be done. Yeah.
I also have a question.
Anybody is not on the spreadsheet, please add yourself to that.
Let's take the.
Huh? No, if you do it on a computer, you can.
Plus theta 1.
Just do it on a computer, don't do it on a phone. On the computer, it works.
So if I
Yeah, we check that.
take calculation, this is like, this is one value, this is another value, this is another value, this is another value. These are all, this is X and this is Y, right? So your training set gave you already the value of these coordinates, X1, Y1, X2, Y